Hi, this is an example video that you might want to share with your students as they're learning how to do good lab reports. Microsoft Paint, as you probably are aware, is a free tool that has been included with the Windows operating system since the early 1990s, I think. Yet many students don't really understand its full power and potential. So I just wanted to show you how you could do a quick diagram with it and how you might encourage them to do quick diagrams that they then incorporate into online or digital formatted lab reports. For example, even in a Google Doc, I find it more convenient to use Microsoft Paint to produce figures simply because I'm familiar with it. So I'm going to do one that is from the mechanics portion of the course. Imagine that you're doing a good old inclined plane experiment where you've got something like a ball rolling down or a cart, low friction cart, and you want to time it. So what I want to do first of all is to show you how I might do that. So the thing that I want to do first of all is start drawing some different objects here. And what I've got on my shapes is a triangle. So I'm going to do a triangle here. Oh, that's not exactly what I want. I want to have a standard ramp, so I'm going to undo that. You probably know the undo arrow is right here. I'm going to go back to my shapes. I'm going to choose the right triangle. There we go. The black color and the line width are the standards. I didn't have to pick that. Now I want to do a ball that's going to roll down here. And the circle or ellipse tool on Paint allows you to do either ellipses or circles, so you got to be careful to draw it correctly. And then if you position the mouse cursor appropriately, you can move it. Look at that. Look at that. All right, now I like to have a little bit of color. So what I'm going to do next is I'm going to flood fill with, I don't know, how about green, the inside of my ball there. So I got a nice pretty image. I would now like to indicate that what I'm going to do next is going to involve drawing data or getting data from these lines that I'm going to draw. I'm going to make a slightly thinner set of lines. I'd like it to line up here with the front of the ball. I'm going to copy that. I'm using the keyboard Control-C, Control-V to paste that. Oops, didn't copy. So I'll just draw another one. And what I want to indicate is that that distance, maybe you should put it down at the end, right there, is going to be called L. So what I want to do next is have some sort of indication that the distance that the ball is going to travel needs to be indicated like that. I like to use little call-out dimensional arrows the way they do on a CAD program. So those make it look a little more professional. Not perfect, but still pretty good. And then I'm going to add some text to indicate that I'm going to call this variable L, and I'm going to set it equal to 90 centimeters. And just to encourage the students to use proper SI units, I'm going to make that also available in metric meters with 2 sig figs. So there we go. And with Paint, I can't tilt that or anything, but I think by position it's pretty clear that it refers to that distance right there. And then the last thing that I might want to do is add some indication of the stopwatch that I'm going to have them use. So I'm going to use a thicker line here. Here's my stopwatch, and I'm going to add 3 little buttons down below because my microns, that's what they have. Oh, that didn't work out very well. That looks terrible. No big deal. I'm going to zoom in on that portion and move over to it so you can see it. And I'm going to undo that last bit. And what I'm going to do next is I'm going to copy the button that I already did. Now I'm using the keyboard Control-C, Control-V to paste it. I'm going to put you right there. I'm going to put you, second paste, right there. Now they all look identical. Look at that. And I'm going to put up in the display here and have something that says T equals 0.24 seconds. And that is a pretty good indication that the information coming from here is a time value like that. I left off the units, sorry. You can complain about that later. Now if I want to see the whole thing again, going back to the view, 100%, there it is. I have a lot of empty space here, so I'm going to select the whole thing. I'm going to bring you up there like that, and I'm going to grab the lower corner of the box and I'm going to shrink this thing down. And with that, I think I'm ready to save. I'm going to go up here to File, Save As, and put it in the directory that I have selected for this professional learning DCSD physics team. It is by default saving these as portable network graphics, PNG files. Those are really nice. And I'm just going to call it example lab diagram. And I can have spaces in there. Some programs don't like that, but this is the 2020s. They'll take it. There we go. Now, if I wanted to incorporate this into a Word document, that is easily done. And I can include the ability to resize it if I want. For the moment, though, I think we're finished. You've seen a quick example of how to use Microsoft Paint to produce a very simple lab diagram. Thanks for watching.